All right, let's get right into it. Floating right above our heads, completely invisible, is a massive junkyard. And we put it there. We're talking about space debris, a crisis that's been building for decades. So today, we're going to break down how we got here, what's at stake, and some of the truly brilliant and, frankly, kind of wild ideas for how to clean it all up.
Just let that sink in for a moment. 10 times faster than a bullet. That's not a sci-fi movie line. That is the terrifying reality we've created in low Earth orbit. We've turned the final frontier from this vast, unexplored space into a lethal, high-speed shooting gallery. You see, the real danger here isn't about size, it's about speed. At almost 28,000 kilometers an hour, even a tiny fleck of paint hits with devastating force. I mean, a fragment that's just 1 centimeter across has enough energy to completely cripple a multi-million-dollar satellite. These aren't just pieces of junk, they're hypervelocity projectiles. So just how crowded is it up there? Well, here's the scary part. We can track about 26,000 objects bigger than a softball. But that is just the tip of the iceberg. The real problem is what we can't see. We're talking hundreds of thousands of smaller, marble-sized fragments and an estimated 170 million pieces that are so small they're impossible to track. You can't dodge what you can't see, and they're all just floating around like ticking time bombs.
Now, this mess didn't just appear overnight. To really get a handle on the solutions, we have to understand how we ended up with a junkyard in the sky. This has been a slow-motion crisis, building up for over 60 years, basically hiding in plain sight. This timeline really shows you how things got out of hand. It all started with just one object in 1957, Sputnik 1. For decades, the problem grew, bit by bit. But then, two key events caused a massive spike. In 2007, an anti-satellite missile test deliberately blew up a satellite, creating a cloud of over 3,000 trackable pieces of junk. And then, just 2 years later, an active American satellite slammed into a defunct Russian one, adding thousands more fragments to the chaos. And these events, they've pushed us dangerously close to a tipping point, a scenario where space itself starts to, well, fight back, threatening the very satellites that our modern world completely depends on for everything from GPS to weather forecasting. This leads us to the absolute nightmare scenario for anyone involved in space, the Kessler Syndrome. It was named after a NASA scientist, Donald Kessler, and here's the theory. One collision creates a cloud of shrapnel. That shrapnel then hits other satellites, creating even more shrapnel. It's a chain reaction, a self-perpetuating cascade that could get so bad it makes entire orbits totally unusable, maybe for generations. So you might be wondering, if it's so bad, why haven't we fixed it? Well, it's a classic case of what's called the tragedy of the commons. The 1967 Outer Space Treaty basically says that orbit belongs to no one. It's an open resource. So companies and countries launch satellites based on their own self-interest, without really having to pay for the collective risk they're creating. It's kind of like overfishing in the ocean. Everyone knows it's a huge problem, but nobody wants to be the first to stop. This whole attitude is perfectly captured in an old fable. A kingfisher is asked where all the fish have gone, and it just shrugs and says, "How could I know?" That nonchalance, that's exactly how we've treated Earth's orbit. The long-term consequences are always seen as somebody else's problem, or maybe a problem for our kids to solve. But okay, it is not all doom and gloom. Humanity is finally starting to wake up to this, and engineers are designing some truly incredible high-tech janitors to go up there and start the cleanup. And seriously, some of these ideas sound like they're straight out of a movie. There are concepts for laser brooms, ground-based lasers that would gently nudge debris out of orbit. People are working on giant space nets, collector satellites that would literally fire a harpoon into a piece of junk. And even these things called electrodynamic tethers that would use Earth's own magnetic field to drag debris down to burn up. It's a whole toolbox of amazing futuristic solutions. But beyond all that brute force engineering, some of the most exciting ideas are coming from a really surprising source: nature itself. Scientists are turning to biomimicry, looking at millions of years of evolution for elegant, efficient solutions to this very modern problem. First up, let's look at the gecko. Its feet are covered in these microscopic hairs that let it stick to almost anything. That's what inspired the gecko kit cannon. The whole idea is to use a gentle, gecko-like adhesive to grab onto a piece of tumbling debris without creating even more fragments. Then, a robotic arm can safely take it away. Brilliant, right?
Or what about the Venus flytrap? The genius of this plant is its efficiency. It only snaps shut and uses energy when something actually triggers its trap. So imagine a spacecraft that does the same thing. It would just drift towards a piece of junk, and as soon as the junk gets close, a mechanism snaps shut, capturing it without needing all these complex, power-hungry targeting systems. Simple, effective, and super economical.
And finally, we've got the remora fish, nature's ultimate hitchhiker. It uses this unique suction pad to attach to sharks and travel with almost no effort. This inspired a device called the remora, a lightweight system designed to attach to a dead satellite and then guide it safely back into the atmosphere to burn up. It's maximum impact for minimal energy, just like nature would do it.
Okay, so as exciting as all these solutions are, and they really are, cleaning up space is, well, it's not going to be easy. Before we get too carried away, we need a bit of a sober reality check on the massive challenges that are still in our way.
The challenges really break down into three main areas. First, the technical part. Trying to crop an object that's tumbling at 28,000 kilometers per hour is incredibly risky. If you mess up, you could actually create more debris. Second, the economic hurdle. A single cleanup mission could cost over $300 million. Who's going to pay for that? And finally, there's the legal and political gridlock. You can't just go and grab another country's old satellite. Even if it's junk, legally, it's still their property.
Ultimately, this orbital junkyard is kind of a mirror, isn't it? It reflects our terrestrial habits right back at us. So as we push further out into the cosmos, we're faced with a fundamental choice. Are we just going to treat space like another infinite dumping ground? Or can we finally learn to be better custodians of the final frontier? The answer to that question is going to define our future among the stars.